Okay, I'd like to introduce Avi Miller, and his talk is I Can't Believe This Is Butter, tour of BTRFS. And apart from ballet dancing across the stage, Avi's also had extensive experience in networking, server and workstation hardware, network, server workstations, operating systems, LAN, WAN, connectivity. That covers a lot.
And interpretive dance, yes.
Well done. Thank you.
Thank you. Yes, I'm Avi Miller. I'm one of the principal program managers for Oracle Linux. I was told by my boss when he watched the live stream on Wednesday very late at night in San Francisco that I didn't plug Oracle Linux nearly enough in my presentation. So I just wanted to highlight that the demos that we're doing, that I do as part of this presentation, are done on Oracle Linux 6.2. And they're using our new Unbreakable Enterprise kernel release 2, which is currently in beta. And the slide deck actually has the URLs for our Yum repository for that beta, as well as the Git tree for that beta as well. So if you're interested in pulling down that code, it is up on the website. But after the talk, and for those of you who were, I actually see some of you back again this afternoon, it occurred to me that the only reason that this talk was voted best of LCA is because I did 3 demos, one of which was added about an hour before I started the talk. And the only reason it was voted up is to see if I could do exactly the same 3 demos again.
Everyone loves a train wreck.
So in the spirit of television cooking shows, here's the one I prepared earlier. I am from the dark side. And those of you who've seen my tag this year is Come to the Dark Side, We Have Cookies. I had cookies, but they're all gone, so the new tag has come. I knew those demos worked. So if everything fails, I have the video from Wednesday morning that I can just replay. Okay. Which is the reason that my talk was slightly fuzzy. Oop, come on. There we go. So, ButterFS. Jointly developed by a number of companies, obviously started by Chris Mason of Oracle. Chris is our director of software development for Linux at Oracle. So he doesn't just write ButterFS, though he should because he's got deadlines. He also manages our entire Linux software development team at Oracle. Obviously, a lot of development coming out of Red Hat, Fujitsu, Intel, SUSE, and more. The core of ButterFS is the fact that all data and metadata are copy on write, which means that we do not modify blocks on disk when we change a file. What we do is we read the original, and then we write out the change somewhere else. Okay, so every change that gets made to the system, what we're in fact doing, reading the original, and then writing out the change. Everything's copied on write. You'll see some beautiful animations later as what this looks like when we start writing out lots and lots of data. One of the other things that we do is that we maintain checksums for all the data and metadata that we write. Okay, and this allows us to validate the data as it comes off the disk again. So you'll see one of the first demos that I do is our scrubbing demo. So the ability for ButterFS, when in RAID 1 and in RAID 10 mode, to detect a failure on one of the disks, and in some cases on the fly repair that data. We have efficient writable snapshots. The keyword here is efficient. LVM does do snapshots, but I'm not sure I'd use that adjective with them. Okay, so our snapshots are writable, they're efficient, the snapshots themselves are snapshotable, the snapshots of the snapshots are snapshotable, and so on. And in fact, you can mount snapshots of the same file system at the same time, all in read-write. Okay, so you can snapshot your root file system, mount both snapshots simultaneously, and then start writing to both of them. The whole thing happens on copy on write, and now you have 2 versions of the whole thing going forward. We have multi-device support because what Linux really needed was another implementation of RAID. But our multi-device support is slightly different because unlike MD or software RAID, we don't do it at the device level, we do it at the file system level. So when you tell ButterFS that you want RAID 1 or RAID 10, what ButterFS is actually doing is ensuring that it has enough copies over the devices that you've specified, not that in a RAID 1 array that the 2 devices are identical. It's just ensuring that data written to a RAID 1 array is duplicated at least once on each device, if there are 2 of them, or 2 devices if there are more of them. You can, in fact, I was having this discussion earlier, you can create a RAID 1 array of 4 SSDs and 1 spinner. It's fine. We'll just make sure we have enough copies. We have online resizing, both up and down. You can add and remove devices from a Btrfs file system while it's running. We have online defragmentation. We have transparent compression. So there are currently 2 compression mechanisms in Btrfs, and the third one's pull request went in the day after my talk. So we have gzip and LZO. LZO is more effective at compressing, but slightly slower at detecting that it can compress stuff. And Snappy has just been, the merge request has just been sent to Chris for that. Snappy has the same relative compression rates as LZO, but it's faster at determining whether data can be compressed. One of the things that Btrfs does is it tests to see if you can compress something first before it bothers to do it any further and actually store the compressed version. Note that once Btrfs decides that a file can't be compressed, it won't ever check again automatically. So if you change the file over time and then you decide, hey, Btrfs should check this again, you actually have to manually try and get Btrfs to compress that file. Very efficient storage for small files, because what we do is we shove the small files into the inodes, we stack them. We have SSD optimizations, which is a bit of a lie. SSD optimizations is in fact just turning off spinner optimizations. Okay, so all we do is just turn off all that stuff that we do to make spinning drives faster, because SSDs are fast enough by themselves. And we now have trim support, both real-time trim and batch discarding. So all of that's already in place. What we're doing at the moment, extensive performance and stability fixes, particularly people who may have tried Chris's 3.3 window merge, which would refuse to boot. Kernel panic on boot, well done, Chris. Significant code cleanups and efficiencies there. David pointed out that our free space mapping in Btrfs wasn't as efficient as XFS is. So we've now added a whole bunch of efficient free space caching so that we're better at detecting where the free space is. One of the problems with copy on write that we discuss is that it can defrag metadata and data pretty quickly because it just keeps writing new stuff all over the place. We have delayed metadata insertion, so now we can batch up metadata for insertion onto disks. We have background scrubbing, and we talk about scrubbing as well. Anybody here not know what scrubbing is? Hands up. Okay, so you lie, Paul. Enterprise SAN vendors and SAN arrays do this. Scrubbing is the act of checking all of the checksums for data to ensure that they all match, essentially. So I'm going to validate that all the copies, when checked against the checksum, are all proper. So enterprise SAN arrays do this automatically on a regular basis, depending on the vendor of your array. Some of them do them continuously. An interesting performance degradation we discovered in one storage vendor's array is that it was continuously scrubbing 20 terabyte volumes. Others do it once a week, once a month. And the nice thing about scrubbing is it continuously checks written out data for bit rot, essentially. Okay, so now we can do scrubbing in the background, and I actually show that in a demo. LZO compression was added, snappy compression is in development, batch discard via an IOCTL, so that instead of doing live discarding, we can now do batch discarding. This is really nifty, particularly in virtualization environments where you create a sparse file or you create a thinly provisioned LUN. Anybody here use NetApps? NetApp storage? So NetApp nowadays does thinly provisioned LUNs. You ask for a 10 terabyte LUN and it gives you a 16K allocation. And then you go and start writing data to that and it gets bigger and bigger and bigger and bigger, and then you go and delete 8 terabytes of your 10 terabyte LUN, but you don't recover that. So what we can do with batch discarding now is we can do hole punching into thin provisioned LUNs. So we can actually tell the NetApp we're now no longer using 8 gigs of the 10 gigs, and it actually deallocates it back out in the thin provision. The same thing can work. We do this in Oracle VM, where we have Btrfs file systems inside a guest running on a sparsely created file virtual disk image on an OCFS2 file system. So OCFS2 1.8 also does hole punching in sparse files. So now what happens when Btrfs does a discard via batch, OCFS2 hole punches the sparse file and then reclaims that sparse file support. Per inode flags to control copy on write and compression, you can actually turn off copy on write compression on a per file basis, or on a per snapshot basis, or a per subvolume basis, and automatic file defragmentation. Okay, so as I mentioned, everything's done copy on write. We have that delayed metadata write system, so now we can actually key order to group all the stuff into the same metadata block. But because we keep copying on writing and file systems are not very static, defragmentation happens pretty quickly with copy on write. Larger block sizes lowers that defragmentation. And here's some numbers that we got on the Intel 120 gig SSD. 4K blocks, which is what Btrfs currently uses, pushing 78 megabytes per second write. Once we started increasing that 8K, 16K, you can see once we buffer up to 16K, we're doing almost double the write speed to a single SSD. So this is queued up for the 3.3 merge. It's one of the things that broke 3.3 originally, so it's been fixed now and resubmitted. Note that in 3.3 we will allow you to create bigger blocks, but the default is still 4K. So if you want to start experiment with Btrfs on larger block sizes, when you make a fest, you'll have to change the block size in the makerfest, otherwise we're going to default to 4K. Over time, Chris's intention with Btrfs is in fact to change the default from 4K to 16K. Okay, cool. So, scrubbing. We store CRCs, or checksums, for every piece of data and metadata we store on the file system. Okay, which means that when we detect a checksum error when we read, we can automatically repair the metadata or data by reading another copy from another drive. So the scrubbing code that was added scans that allocated data automatically. We either do it on read, and we automatically do it now on read. The problem with that is that you can have a drive full of data that you never read. And if you're in RAID 1 array, Btrfs's Btrfs's RAID 1 is slightly, well, it's actually very deterministic as to which copy it reads a particular block from. So you'll see this in the demo. When I demonstrate one of the blocks corrupting, Btrfs is either going to automatically fix it or not. And the reason for that, it's only ever going to use one specific copy when it reads. So the problem is, if you're running all the time and you never scrub, and you lose the drive that had the good copy, you now just have a bad copy. So once you go to RAID 1 or RAID 10, scrub often. At least once a month. We recommend kind of once a week. The best case scenario, because you can scrub in the background, start a scrub, get a status, work out how long it takes, apply liberally. So you can determine, your enterprise SANs are doing this already. So now we can do the same sort of scrubbing just on the file system. And let's, all together, let's try a demo, shall we? Right. Oops. There we go. Okay. So, whoops. Let's go full screen. Everybody see that? Should be pretty cool. Okie dokie. So just to give you an idea of what I've got, this is a Oracle Linux 6 system. Everything's currently running ext4 and stuff like that. So I'm going to create my first Btrfs file system. I've got SDB and SDC, two 8 gig drives, virtual disks essentially that are sitting there unused. So here's something nifty. That's how fast Btrfs's makerfs is. It's that speed regardless of the size of the disk that you're creating Btrfs on, because we don't actually write anything out. I mean, I think we write about 2 megs, I think, all up. And I always forget to do this before I try to mount, just to make sure I've got it. Because I had no Btrfs volumes before, so it wasn't loaded automatically. Notice that that speed, I can actually have different RAID levels for metadata and data. So I can say the metadata should be RAID 1 and the data should be RAID 10. Again, this is not device RAID, this is data RAID. We're just ensuring, Btrfs will just ensure that it has the same amount of copies. So let's make the Btrfs, BTRFS, and let's mount devsdb to Btrfs. Whee! So that bit worked. First lie that your system is going to tell you is if you do a DF. Okay, DF lies. First of all, that's the first lie. This is a RAID 1 array of two 8 gig drives. A RAID 1 array of two 8 gig drives actually only has about 8 gigs available. So that's the first lie. That's the second lie, because we haven't actually only used. So if I copy something to it, let's copy vmliners to Btrfs. There's another lie. So let's sync a few times now, but it should be telling me something a little bit better. Okay, so DF is just going to lie to you all the time. Okay, so we wrote Btrfs file system DF. That's a better one. So now it's actually telling me how much it's really using. The RAID 1 for data, it's allocated 1 gig so far. Again, it hasn't created a RAID 1 array of the two devices. All it's going to do is ensure that we have 2 copies of each piece of data and metadata on at least 1 device each. I've used 3.98 megabytes. But DF said I'm using 8.1 meg. It's doing compression. So a total of 8 megs is now giving me the uncompressed space that I'm actually using. So I'm actually the file that I copied in is actually 8 megs, but I'm using 3.98. The metadata, I've again allocated 1 gig. Btrfs is now allocating different chunks. So it's allocated a gig of data and it's allocated a gig of metadata. So one thing to note, if I do fairly low metadata changes to this, the maximum amount of data that I will be able to store on 2 8 gig drives in a RAID 1 Btrfs array is 7 gigs, not 8. Because it's already grabbed 1 gig of metadata space. And keep that in mind as well. Okay, so now let's break things. BTRFS. So FileFrag tells me where this file is actually sitting. If I need to work out, I go 496 times, actually let's just copy that out. 496 times that is so. Okay, I need to unmount Btrfs first. Really nifty testing tool. Never use this in production. Great for testing. The other big warning that I'll give you, Btrfs corrupt block defaults to corrupting all the copies of the block that you specify. So in this, because I'm only testing the scrubbing code, what I actually want to do is tell it to just, oh, no, it's all right. I just want to corrupt the first copy. There we go. So it actually went and copied, and I specified devsdb, but it actually corrupted it on devsdc, because that's where copy 1 is for that particular block. Notice that I can refer to devsdb always. In fstab, if I want to mount this entire array, I just specify devsdb, and Btrfs sorts it out. It'll mount all the devices in the array automatically, which is where proc mounts will lie to you. Because it'll say only devsdb is mounted, but in fact, it's using both devsdb and SDC. The nifty thing about this is that we can add devices to the array without having to change fstab. We just keep adding devices, and we can refer to any of the devices in the array. I could say mount devsdc, which I'll do in a second. So now, I'm going to remount the device. Still mounts. And in fact, now it's telling me that devsdc is mounted. It's not terribly good at knowing. I just told it. It's actually mounted both. I can sum Btrfs. There we go. And let's check the MSG. And Btrfs has automatically detected the checksum failure and corrected it from the copy. Okay, so that happened on the fly. So, well, the first one worked. Woo, good start. Let's umount dev SDC again, and let's go back and corrupt the second copy. So now we're actually corrupting the copy on dev SDB, and I can do a mount dev SDC, Btrfs, and I can do a Btrfs file system, oops, scrub. Ooh. Where is my scrub? Scrub start, they changed that for me. Btrfs scrub start, Btrfs. Goes and happens in the background. If I want to find out what happened, btrfs. There you go. So the scrub started and finished after 0 seconds. It scrubbed 7.76 megs with 2 errors, the read error, the checksum error, and it corrected the error for me. So now the file is fixed again. Okay, so the scrub is something that you want to do on a regular basis in RAID 1 and RAID 10 arrays, because you wouldn't want to have been in the position where I corrupted dev SDB and then I lost dev SDC, because then the one remaining device in my array actually had a broken block. So you want to scrub so that you fix the blocks that you don't read very often. Obviously, we're going to scrub on read, but again, we're only going to fix blocks that we read, and we're only going to read off dev SDC, because we're slightly deterministic. Okay, so that worked. Awesome. Yes?
For you. What's the rough scrubbing speed?
I don't know, but it's now multi-threaded, and it can be ionized down.
Yep.
So you can adjust the rate of scrubbing, and it is worth testing how long scrubbing takes and the impact of scrubbing on your system. Okay, so that you can adjust, particularly with ionize, if you want to reduce the impact that scrubbing has on a live system, or do it after hours. If you have a usage pattern that says, Sunday evenings is not a very busy time for this particular system, scrub on Sunday evenings. Which is a good, by the way, tip for your enterprise SANs as well. I had a customer with a SAN that started scrubbing sort of middle of the day, and they couldn't work out why they were getting database performance loss at 2 p.m. on a Tuesday for some reason, and the database itself wasn't doing anything more or less. It just started getting very slow. And it was scrubbing, kicking in on the SAN. Okay, so discard and trim, I've spoken about this already. They notify storage that we're done with a block. A lot of SSDs now do this themselves. They have pretty good usage detection and internal sort of trimming, but the nifty thing about this is we can do this on not so great flash and not so great SSDs. We can do this particularly to embedded devices that use fairly cheap flash. Okay, so Btrfs is actually quite friendly to small embedded devices. It was in Migo and Moblin and now in Tizen. Is that right? Yes. So we do real time with the discard option, discard mount option, -O discard to mount. We'll do real-time discarding, or batched. Batched is particularly useful for virtualization style or thin provision style, so you can do sparse punching. Okay, so you do a batched trim, and then your enterprise SAN or your virtual disk array will just punch a hole, and that's controlled via IOCTL. Drive swapping, which was a Google Summer of Code project. Basically, when we rebuild an array, we actually do it via the rebalance code. This goes back to the fact that Btrfs is not doing device mirroring, it's doing data and metadata mirroring. So we can rebalance, you start with one device, you add another device, then you go Btrfs rebalance, and it ensures that it's now got copies. Then we add 2 more devices, and we do rebalance, and then Btrfs spreads that. Because, of course, for performance, it's faster if we've got 4 devices so we can read off all of them. If you've had a RAID 1 array with 2 devices, you add 2 more devices, rebalance, so that you can now start reading and writing to all 4 devices. Well, write to 2 at a time, read from 4 at a time. Okay. Drive swapping allows us to replace a disk in place. So I can add a new disk, and I can do a drive swap, and you can do this from any number of source drives. So you can take a, a RAID 1 array of two 1 terabyte drives, add a 3 terabyte drive, and swap multiple drives into the new one, which is pretty cool. Use extent allocation to limit and restripe between RAID levels. That was pulled on Wednesday morning, which means we can start with RAID 1 and we can use the rebalance code to restripe it to RAID 5, RAID 6, or RAID 10. Again, because we're not actually doing device mirroring, we just rebalance the data and metadata across the devices that we're given at the RAID level that we're given. My lovely friends over in the Solaris side of the buildings tell me that it's never going to be competitive because they have ZFS send and receive. We have Btrfs send and receive in development now as well. I didn't get to demo this on Wednesday, so those of you who were here, I urge you to go and look at Btrfs find new, because we track all the changes that happen inside the metadata, which is used by Btrfs send and receive, so that we can very, very efficiently stream data from one Btrfs file server to another. So that's in development. Go to Bug Yan for that code. It's on his Git repo. I got it to work, and then I broke the VM that I was on. So it does actually work, but it transmits in neutral format, so it's not actually corrupting. It's not actually transmitting corrupted blocks. So as I mentioned, we're fairly friendly to small machines. We're not so friendly to small disks, as that Btrfs file system DF showed you. Because I wrote all of 8 megabytes to the file system, it already allocated 2 gigs worth of data, 1 gig for metadata, 1 gig for data. We tend to not be as efficient. We're getting better. You can adjust that allocation. It works very well on low-end flash because of the copy on write. It's inherently load leveling, even if the controller inside the flash doesn't load level itself. Okay, we inherently load level because we're just continuously copy on writing across the whole thing. RAID 5 and 6, the implementation was done from Intel. Its merge is pending the completion of the file system check, which I have no more information on except to say that Chris is giving a presentation on Btrfs in LA tomorrow. That's all I'm allowed to officially say. What he says at that presentation might be interesting. We'll add triple mirroring, so the somewhat equivalent to RAID Z from ZFS, part of the RAID 6 implementation, and we add the ability to mix your RAID modes. So you can have RAID 1 for metadata with RAID 6 for data, or RAID 10 for data, RAID 1 for metadata. You can start mixing and matching your RAID modes. And this is the big one. What happens when, for those of you who ran Btrfs about a year ago, inevitably you came to the point where your entire file system just decided it was stuffed. So there are a couple of ways of recovering. There is Joseph's read-only recovery tool. It's actually called Btrfs Recovery. What it attempts to do is basically suck as much data off a corrupt Btrfs system as possible and copy it somewhere else. So you need a target file system to copy to. But we do now have the tree root history log. So Btrfs maintains almost a circular log of changes to the root file system, to all of the checksum trees, all of the metadata trees, so that we can potentially roll back. The file system check is on the way to replace in place, and Chris is talking about, as I mentioned, Btrfs, but you can get the recovery beta tools from his Git repo. So let's do something fun. Whoops. Okay, so now let's go and take out that copy. No, sorry, I know what I needed to do. I needed to do Btrfs debug tree. Just show you this first. Okay. This is showing you the current circular root tree logs. So the current positions of the extend tree, the device tree, the file system tree, the checksum tree, data relocation, and all the backup slots. Notice this is a rolling circular log, so there's Gen 13, we have Gen 14, Gen 15, and Gen 12. So in fact, we've already rolled. So the currently active one is 13, we've got 12, we've got 14 and 15 going. So let's go and grab the checksum. The point at which, we actually use the checksums to validate the data. So let's grab that and kill it. Boom. I'm now corrupting both copies of that block, which is in fact the checksum tree for the file system. So if I now try to mount, it goes, no, I can't. If I look at DMSG, I've got lots of bad trees, and the opening of the checksum tree completely failed. What do I do? Oh no, help me, Obi-Wan. So, how do I fix that? If I type correctly, I do that. And we're mounted. And if I go and sub, if those of you who remember numbers, Btrfs has fixed itself. Okay, so mount minus O recovery basically tells Btrfs walk back through the root trees and find one that mounts. That circular root log is done every 30 seconds, so we have 2 minutes. Worst case scenario, if I was writing to this file at the time, I've lost up to 30 seconds worth of data. But probably not. What I've lost is up to potentially 30 seconds of metadata, because the data itself is copied on write. So it's still writing ahead, it's still not replacing the old data, it's still consistent. It may be 30 seconds old, potentially. There are times, depending on which block was corrupted on both. Question?
Is it just that file that you'll lose after 30 seconds on?
The question was, is it just that file I'll lose? It depends on which block was corrupted. So if nothing else was touched but the block in that file, potentially just that block, yes. Or potentially no data at all, depending on what was actually corrupted. It was just metadata for something else. Minus O recovery will go back to a previous known good, which could have been identical to the value that was corrupted. So you may not lose any data at all. Cool. So now we've got 2 of the 3 demos working. Yes. Okay, thank you. I'm going to rush ahead. What happens when you start creating billions of files? David loved this one. So there's a dramatic difference in file system write-back. The sequential I/O still matters. The file systems have different patterns for write-back. I will say that ext4 and XFS used to get stuck behind their journals, but XFS, as David showed in the second presentation after mine, has gotten a lot better. So let's take a look at some pretty pictures, shall we? This is ext4. So this is what happens when you write 1 billion 0-byte files on ext4. So there's a point on this disk that keeps getting, you can spot the bottleneck fairly easily, and all the rest of the data is just splattered across the disk, essentially. So you'll notice it's kind of maxing at around 30-something megabytes per second with lots and lots of seeks. XFS is much prettier. So XFS's multi-threaded writes does that. That's great. But I'm still stuck behind the journal. At this stage, I'm stuck behind the journal. So you can see the seek pattern bouncing up and down. What happens when we go to Btrfs? This is what Btrfs looks like. Okay, so very, far more flat seeks per second, much higher and flatter megabytes per second, right? And that's the copy on write for metadata. So all Btrfs is doing is just sequentially writing, and all the metadata is blocked together. Yes, David?
One thing I just noticed there,
yes.
if you look at that, go back to the XFS one and have a look at how many seeks a second it's doing.
Oh yes, much less. Yeah. XFS does much less seeks per second than we do. Absolutely. Because of this, it's all this happening in the background. So all this read that goes on behind the write, because as we're validating all of the metadata that happens, yes, we do way more, we do about double the seeks per second that you do. Yeah.
That was about 50 versus, what, 1,500 there?
Oh yeah, and that's, sorry, about double we do more seeks per second than X4 does. And this is tiny. The XFS's seeks per second is very, very low. It's very cool. Yes. I said that. Okay. So that's kind of the benchmark. I'm going to skip through these because I know you want to see the last demo, see if that works. So that's where the file creation throughput is, and that's the IOPS. So notice Btrfs's overall IOPS is actually lower, sitting there, but XFS is at that stage was in the middle. The I/O animations, X4 was seeking between a large number of disks, sort of splatting all about. XFS is walking through a series of areas, which is very pretty to watch. Those of you who used to go into sort of Zen meditation watching a defrag, You can now do it watching SeqWatcher on an XFS file system. It's very pretty. Very heavy logs on XFS and X4, and we're doing sequential writes and random reads. But this is the fun demo. Okay. So we're going to take Btrfs into production with Oracle Linux 6.2 when we release our UEK2 kernel into production. One of the reasons we're going to do this is because of something called yum plugin fs snapshot and the ability for Btrfs to snapshot a file system. So what I need to do is actually convert my root file system to Btrfs. The quickest way to do this, oddly enough, because RHEL 6 doesn't have Btrfs in Anaconda, Oracle Linux 6 at the moment doesn't have Btrfs in Anaconda either. So the quickest way to change this is to boot into Fedora on a live CD. So let's go ahead and do that. Yeah, they'll stay, don't worry. Come on, chug.
While you're waiting for that,
Yes.
what's the tool that you use for doing the fancy these videos?
That's SeqWatcher on Chris Mason's oss.oracle.com site, so oss.oracle.com/mason/SeqWatcher.
They were on spinning disks, right?
No, those were on SSDs. Yes, but it's the same sort of pattern. Go away, Firefox. Okay. So, I want to convert to Btrfs. I go Btrfs convert, dev sdb. Oops, that's not, it's actually on the, it already is Btrfs. It is dev fg6 lv root is the one that I want to convert. What Btrfs in fact does as well is it takes a snapshot of the current ext file system and stores it on the Btrfs file system. So if you don't like Btrfs, you can go back to where you were before you started and convert back to X3 or X4. So we'll take you back if you don't like it. The other thing I also have to do, obviously, is change fs tab. Otherwise, it's not going to mount. So now we are in. Let's go back there. Oops, there. And go and drop the CD out. Come on. There we go. Time is of the essence. Come on. There we go. It's booting. No, it's not booting. Ah, I knew it was never going to work, was it?
Video.
Oh, it didn't change. Oh, because I changed the live system. I didn't mount the new file system. Ah, user error. You know you want to work this time. Here we go. Cool. Okay, so what I want to do is ensure that I've got yum plugin fs snapshot installed. And then do something very silly on a server. Let's install X, because every server needs a GUI. There are ways, by the way, if you're Oracle DBAs, you really do not need X to run the Oracle Database OUI graphical installer. Please come and see me. Don't do this on your live servers. There's something called VNC. It's very cool. It runs the OUI quite nicely. Yes, this is installing to a virtual disk image on an SSD. For those of you who are wondering why Yum is so fast in a virtual machine, it's because the underlying disks are SSDs, and of course Btrfs is really efficient. Plug, plug, plug. Okie dokie. Almost there. Any questions while this yums away? Oh, yes?
Yeah, when you mounted it as DevSDB,
Yes,
you can add drives into that volume.
correct.
What happens if you take SDB out of the volume while it's mounted?
It will keep going. So I mounted on DevSDB. What happens if I drop DevSDB from the array while it's mounted? It'll keep going. It's quite happy.
Except when you go to try and remount
Correct. Then you have to at least target one of the disks in the array.
from FXTab if you want to
Yeah.
make that as
Yes. Okay, we're almost done. Done. All I want to do is change this to 5 and reboot. So one of the things that I didn't highlight, by the way, before Yum rushed ahead, is that Yum actually snapshotted the file system just prior to applying all of those RPM updates. So what's going to happen now, as the machine boots, it should hopefully, there we go, goes into a UI, and it's going to run first boot for me, because of course that doesn't get installed by default. So it only got installed, there we go. Come on. I need the forward button. Visible, forward, yes, I agree. No, I don't want to register. Forward, no. Forward, forward, yes, sure. Finish. Okay. So there's X. What I need to do now is, oh no, I really didn't want X on my server. So let's go and do Btrfs Btrfs subvol list. So those are the two subvolumes. You can see Yum is ID 257. I want to go back to that. Reboot. I don't like what happened since between now and then. So let's edit. And tell it to use subvol ID 257 instead. You can see there it identifies subvol ID 257, boots the system, I log in, and I don't even have startx installed anymore. But I still have the original, and I can go and mount it. So if I want to compare the two file systems, I've still got subvol ID 0. And I could mount that at the same time as subvol ID 257, both read-write, and start doing stuff with that. So thank you very much. If you have any more questions, I will be around. Cool.
Hello. You want to ask a question? Yeah, there's time for questions while the man's unpacking.
Is there?
Yep.
Oh, cool. There's time for questions.
There is. You're so efficient. And your system's so efficient.
Any questions? Oh,
6 minutes.
blue shirt in the end first, and we'll work inwards.
You showed when you had a multi-volume mirror that you could mount it by any named disk.
Yep.
You mount it by UUID instead.
Yes, UUID, label. So can you mount by UUID or label was the question? Yes, you can.
I guess more importantly, does it find the other parts of the volume
Yes.
by UUID? So he doesn't care if the device is moved around.
Correct. Yeah. And something to note though, Dracut in the released version of OL6 doesn't actually do multi-device detection, so there will be a patch. When we release UEK2, we actually have patched Dracut with the Fedora upstream fixes for multi-device Btrfs. So when Dracut actually scans devices, it does the proper multi-device detection for Btrfs arrays. One in?
If you change your mind a second time and decide to go back to that X, is it smart enough to handle branching?
No. So if you, so the question was, if you want to go back from Btrfs to X3 or 4, notice that we only store the X2 data. We actually don't store, so we basically recreate the X3 or 4 file system, but you lose all the changes that were made. and you lose all of the snapshotting and everything else that happened post the conversion. So if you go back to the point just before you convert it to ButterFS.
Yeah, what I actually meant was when you got rid of X by reverting back.
Yes.
If you change your mind at that point and want to go forward.
Sure, I just reboot.
Oh, okay, so it's preserved in the sort of tree.
Yeah. It's copy on write and it's writable snapshots. If I wanted, oh no, I really do want X, reboot and don't specify a different subvolume, and it'll boot the default subvolume, which in my case was 0, and then everything was back in place. Yeah.
I had a friend who was doing BTRFS RAID setups on uneven number of disks.
Yes.
And he got a lot of usage, say 50% waste in metadata.
Yes. We're a lot better at that now. So what happens when you have ButterFS on multi-volume RAID sets that are uneven? ButterFS, was this about 9 months ago?
No, more 2 or 3.
Okay. He should rebalance, essentially. So one of the things that if you have multi-device arrays that are not even, it pays to rebalance every now and then. So ButterFS can then load level better on uneven arrays. Because for performance, it just splatters, essentially, across those multi-devices.
With that subvol thing, is there any utilities to merge again? Because you sort of metaphor, can you merge?
No, just delete a subvolume.
But if you've made changes in, say, both, can you actually go on from each of them?
Yes, you can go on from each of them.
And so you just like run like a diff over the whole thing?
There's ButterFS Find New that will show you the changes between them, but there isn't something that will merge them back into a single no.
The lies for DF, are they intrinsic? Do they have to stay?
Yes. Yes, to the nature of how at this stage, nobody wants to change DF to be file system aware. So DF is just reading what it gets out of. Chris, I will admit, Chris explained this to me last week because I asked him, why does DF lie? About 14 seconds into the explanation, I glazed over. There is an explanation. Bug Chris on the list for it because it's fascinating, I'm sure, for file system authors. Riveting stuff. There was one, and it made perfect sense, and then, yes. There was another question? Oh, Florian?
Yeah, do you have any comparison for snapshot performance of ButterFS versus the stuff that just went upstream with the re-implementation of snapshots after ThinkP was merged?
I don't. So do we have performance differences? Chris would have them.
Okay.
Yeah, so ask Chris for performance stats. We're currently, and David would love this, we use the XFS test suite for ButterFS, because it's great. So we're now currently doing QA testing for ButterFS on our kernel, because we can actually support it in production. And we have all the performance stats that come out of XFS test and things like that as well. So they would be there. It's worth asking Chris.
Can you create hard links between files on different ButterFS subvolumes?
Good question. Can you create hard links between files on different ButterFS subvolumes? A very good question. I have no idea. Go and try it. Report back to the group when you're done. It's a great question. I like that one. Yeah.
Are you going to do something like L2R?
Are we going to do something like L2R? What is L? I'm going to expose my ignorance. What's L2R?
In ZFS, it has a way to do caching on, like, put an SSD on a spinny Rust array, and it will do, like, right through caching.
Oh, you mean sort of hybrid storage style where we cache out? I don't know. Theoretically, the capability is there. So Chris can determine relative speeds of devices inside ButterFS arrays. We actually spoke about this as to, can I create a RAID 1 array between an SSD and a spinner? And will it then prefer the SSD and use the spinner if the SSD fails, kind of stuff? And Chris's response was, the capability is there. I mean, the potential for capability is there, but nobody's written it yet. Yes?
About 9 months ago, there was a patch set posted on Linux FS-devel lists
Yep.
that did hot block tracking and enabled ButterFS to move frequently hit blocks from one device to another. The stuff works, but the almost unanimous comments on it was that that functionality belongs in the VFS because
Yes.
it's file system independent.
Yeah.
And should be implemented for all file systems, not just.
Yes, I agree. I got this one on Wednesday as well. Dedupe, theoretically possible, not currently implemented. I believe that there is a proof of concept code though. So I've in tracking the Btrfs mailing list, have seen proof of concept code. The difficulty, if you, for example, if you play with dedupe on ZFS, it requires a lot of memory. It's not as friendly to embedded small devices to try and maintain dedupe, but it is something that would be possible. Certainly just by abusing the compression code, stuff like that.
Per file, no data cap? Per file, no data cap?
Correct, yes. So can you do no per file, no data cow? Yes, you can. So you have per inode settings for both cow and compression. Yes. Oh, question on here?
How appropriate is Btrfs for an OS volume versus a database or file storage volume?
It's absolutely perfect for OS volume, absolutely perfect for binaries, it's absolutely bad for database storage. And David and I agree that the ultimate server, Btrfs for root, Btrfs for binaries, XFS for data. It's fantastic, best of both worlds. Yeah. Because of all the metadata that Btrfs is writing and all the copy on write stuff, and the fact that Btrfs gets very fragmented because of all copy on write, the sequential read capabilities of Btrfs degrades very, very quickly. So, we have people coming in, that's probably about it. Thank you very much, guys. Ladies,
very much,
gentlemen.
Thanks again.
More dance!
Need music for that next time. Where was that lovely, royalty-free music that was being played this morning?
All right, mute. Very good. I was going to crack a joke. Are you muted?